So I'm going to carry on with the type checker, and I want to add some checking to return statements in function declarations. So it seems like a good opportunity to also create a function type, and then we'll just record the expected returns in the checker, and whenever we see a return statement, we'll check that the types actually match up. So I think we'll start with maybe the cache, because the cache is going to need to provide some function types. And the way that I was thinking of doing this is going to be a map to function pointer by some hash, and the hash will be a hash of the IDs of the parameters and returns, so it will be the signature of the function. But since it will be keyed by a hash, there is the possibility of collision, so I'll need to make this a slice so that I can loop through them and check that the parameters and the return types actually match up before I return it. If they don't, then I can create a new type and push that onto the slice. So I'll need another function basically the same as basic here, just called function. And this will return some function pointer. And instead of taking a basic kind, I'll basically pass in the params and the returns here, which will be a slice of type. So I need to create some hash, and the easiest one that I can think of is fnv1a. So if we just go and get the values for this. So the FNV prime for 64 bits is this. And the offset is this. So we'll have some key, which will be a uint64. And the reason for uint64 is because the IDs are also uint64. And then I'll just loop over each of the params. And to do fnv1a, I need to take the key, XOR it with the parameters ID, then take the key and multiply that by the prime. So we'll do that with both the parameter IDs and the return IDs. So we'll say returns here. And that gives us the key that we can use to look up into the function member. So we'll say, or the function field. So we'll say function by key. If we're creating a new type here, we'll have a new type called function. It will get an ID like normal. We'll pass in the params and the returns. And then when I look this up, it's actually going to give us a slice of types. And I want to loop over them. So I want to loop over and say type range over types. And I want to say if the type matches with the params and the returns that were passed in, then I'll return the type. Otherwise, we'll fall through. We'll check the cache again. If we found it, if we found a slice, we'll check through the slice again, only returning if we find a matching one. If we didn't find one, then we'll create one, and then we'll append it to the cache, and then return it. I think that's enough for the actual cache function, so I just need to create this function type now. So function type is going to have an ID, params, which is a slice of type, and returns, which is also a slice of type. So this will implement the, actually, now that I think of it, the type interface should probably also include the string interface, the stringer interface as well. because I'll need to print them out for the tests, and it will be a lot easier to do it with this. So we'll say that a function can return ID, which is just returning f.id. We'll take string. So for this, we'll have a slice of strings, and we'll build up the params first. So we'll say param is range over f.params, and we'll append to the strings. So we'll say append to strings the param.string. Actually, I think I'll just call this params. Then we can do the same with returns. Then we'll have some string which will be the name. So this will start with fn. If the length of params is greater than 0, then we'll just append by saying we'll wrap these in parentheses like this. And we'll do strings.join params by space. And then the same thing with returns, but this will also have a little arrow before it to indicate that these are the returns. Then we'll just return the string. And function also needs another function called matches. So this will take params and returns, which are a slice of type, and it will just return a bool. So if it gets to the end, we'll say that it's true. And then all we have to do is say, for example, if the length of f.params does not equal the length of params, or the returns don't match, then we immediately return false. Otherwise, we're going to go through and check all of them. So we're going to say param range over f.params. We'll take the index here, and we'll say that if param does not equal params I, then we will return false. Maybe on here I'll do param ID, just in case. They should be the same either way, but I will just leave it with comparing the IDs for now. So we've got ret and returns. So if the returns don't match, then we'll return false as well. So that should cover the caching and creation of function types. So let's go to the checker test. Let's say we've got a function here which is no params, no returns. This should just give us a function with no params, no returns, and an empty block. So I'm going to put the function type onto the identifier here. So we'll put fn, and that will be it for this one. There aren't any params or returns. And I'm not actually parsing params right now, so I can only test returns anyway. So we'll do single return. And we'll do multiple return. So in the single return one, we'll return, for example, an S32. And this one will be, it will have the arrow and then parentheses with S32 in it. This one will also have the arrow, but this will have S32 space S64, let's say. S32 followed by S64. Go test. Declare did not use type. Let's just go to that. There should be types. Okay, so we want this, but we got this, so we're missing the return. We're missing the type on these. Oh, I also forgot to include the returns parts. of the AST here. S32 and S64. Okay, so we just need the printer now to print on the identifier of a function declaration. So this will be basically the same as the other ones. We'll look up the type. So for this one, we want the ident to be sprint of node.ident, passing in the file. Then we'll do this if statement, adding on to the ident if needed, and then we'll append the ident. So right now the checker isn't actually associating the function declaration node with any kind of type. So we'll have to go and do that next. So when we get to function declaration here, we need some params, which is some slice of types, and we also need returns. We don't actually store params right now because we don't pass them, so that can stay as an empty or a nil slice. The returns will do for ret range over node.returns. And here we'll basically just append on returns. So we'll say append returns. This will be tc.check. We're going to check the ret on file here. I think that should be enough. I don't think I need to attach. I don't think I need to associate a type with the actual return node, because the return types here are just going to be part of the function type as a whole anyway. So I should just be able to skip that. And then down here, I'll need to set the node type for the function declaration. And we want to set it to cache.function, where we pass in the params and the returns. Too many arguments. Ah, yes, I don't need to pass file into here. So now we get a panic on line 84. So that is because I am not handling idents just yet. Yeah, so unhandled ident. So to deal with identifiers, because the S32 and the S64 are identifiers that should be used to look up a type in the scope environment. So I'll need to create an environment type now. So this will be env struct. We're going to have an optional parent, which will be a pointer to a parent environment. And then we'll have all of the symbols in the current environment. So this will be a string to type. We'll have new env, we'll take in the parent. We'll return a pointer to env. So parent is going to be parent. And then symbols is going to be make map of string to type. Then we'll need a couple of functions. So the environment I want to have define. So this will define a name, the name of a symbol to go with a type in the current environment. And I want to allow all variables to shadow every other variable, regardless of the type. So I just need to allow it to overwrite the type in the symbols table. So we'll say e.symbols name equals type. We don't need to do any checking or returning errors here. The next one is going to be lookup. So lookup. This is going to return a type based on the name. So if we find a type in symbols based on the name, we'll just return it. If we didn't find it, we want to look in the parent if it exists. So if parent does not equal nil, then we'll return the e.parent.lookup for the same thing. And if we didn't find it at all, we'll return the cache.basic invalid. So that's the environment, and now check actually needs to take in an environment because it's going to be just a normal lexical scoping based on blocks. We'll take an environment pointer here, and that means that every call to tc.check also needs to pass through the environment, and this is going to be our global environment. So this is our beginning one. So if we've got a new environment that doesn't have a parent, that is our global. Then when we get to an ident, we just want to return we want to set the type on here, I think. Maybe we'll just start by looking it up. So we'll say env.lookup, and this will just be the node.name. Because we already have the lexeme of the ident on the AST node. So we can use that to look up in the environment. Then when we come into the function declaration here, we do a check on the body, but we want to create a new environment for the body because the body counts as a block statement. So I wonder if I should just do this sort of explicitly at this level, or if I should overwrite the environment in the block statement here. Since every environment we should start a new environment on every block statement, so maybe what I'll do here is say, we'll just say that environment equals new env where we pass in the environment. And then if we need this parent one, we'll just save it out in a different variable here. I think that should handle the environment okay. So let's just see how this goes. So I need to handle printing now. Since types now all include the stringer interface, we can just return type.string here. And now we get invalid for these type idents, and that's because they don't exist in any of the environment yet. So when we hit the S30, say S32, we want it to look up the type in the environment. Since this is a built-in, we're not expecting a user to define a type or anything yet. So I'll need to define this manually in the global scope. So we'll say global.define, and we'll define S8 as being cache.basic S8. We'll do the same with 16, 32, and 64. So that all passes. Next will be to make sure that the return statements are actually being checked. So right now, these tests should actually be failing because we don't have any return statements. This one at the top will be succeeding because there is no return. But these two should fail and produce an error. So we want to keep track of the expected returns. So we'll do that in the checker itself. We'll just say that returns is a slice of type. And we'll need to start generating errors as well, which is probably going to be pretty similar to the parser. So we'll just take the parser error code here. So that means that we're going to need to reset state as well when we call check. And we'll take the error helper. I think that's all of the error helper code. So in returns, when we go into the function body, we'll set tc.returns equal to returns, and then after the body we'll set it back to nil again. So that way when we get to a return statement, we can check to see if the returns actually match, but that doesn't cover a missing return. So maybe we'll just have, for example, return checked. And this can just be a Boolean. So return checked, whenever we come into a function declaration, we'll set the returns and we'll make sure that this is false. And then after the check, we'll set this back and we'll say if we didn't do a return checked, let's set that back after this. So we'll say if the length of this is greater than 0, and we didn't do an actual check on any kind of returns, then we'll generate an error here. So this will be tc.error. And we'll take the, maybe in this one, I should just pass in a node. So error, instead of taking an offset, we'll just pass in a node, ast.node. And then we'll get the offset by just taking the node.span. So when we generate an error, we can just say tc.error, pass in the node that the error is for. And then we'll say, we'll just say expected return statement or something like that, or missing return statement. Okay, that will do for now. So this should generate errors. So this is still saying that it's passing. Let's have a look at these values. And we'll just make it fail all the time. So we'll say t.error. Okay. Oh, okay, yes. So it is working. I just need to actually check for the errors. So let's go back to the parser. We'll go to the parse function. And I need to take this check to actually return the error. So after we've done the check, we'll check to see if there are any errors that have been generated, and if there are, we'll return them. Okay, so here we've got line 16 missing return statement, and that is correct for this one here, line 16 missing return statement. And line 13 missing return statement as well. So that's also correct. So now we can fix this by saying return, let's say 1, 2, 3. And that means that this block will also need a returns 1, 2, 3 in here. And we'll do the same thing down here, returns 1, 2, 3, 4, 5, 6, return 1, 2, 3, 4, 5, 6. Okay, so we've got another panic because I'm not handling the return statement in checker. So checker, I need to now handle the return statement. So at this point we can say return checked is true. Then we'll say, let's say if if the length of, okay, let's say want return count. Want return count will be the tc.returns length. And we'll say the got return count is the node.returns. So if the want returns is 0 and the got returns is greater than 0, then we'll do tc.error, we'll pass in the node, and this will be something like unexpected return statements. Maybe we'll put this in a switch. In the other case that they don't match, got a return count. Here we'll say expected this many returns, found this many. And then in the default case, we'll just loop over all of them. So if the lengths match each other, then we'll loop over them. So we'll say for ret, let's say for want is range over tc.returns, and then we'll say got is the node.returns I, but we need to change this into a type, and we should check it, so we'll say tc.check. It would then also be worth tagging these with a type so they can be used in code generation. So we'll put set node type, node.returns I, and then if want does not equal got, then we'll say tc.error node.returns. I think I'm just going to do, we'll call this ret here. So this node generates the error expected something, found something else. So we'll say this will be want.string and got.string. And a return statement itself should just return nothing. So we'll say cache.basic invalid will be the type of the return statement itself. Node.returns is undefined. Oh, this is the return statement, so this should be expressions. Then we don't have an I here, so that needs to be changed. Then we've got undefined got test count. This should be return count. Not enough arguments in tc.check. This needs to pass the environment through. Okay, so now we are saying checker.fin line 21 column 9, which is here, is returning an untyped int, but we expected s32. So that seems to be correct. But we do need to make sure that we are propagating a more concrete type now. So we'll say before we okay, I think I will just take the propagate code from here for now. So we'll say type is tc.check expression environment. We'll pass that type into here, And this can just do the same check at the moment where it sees if it's untyped int, and if it is, it will set it to this S32. I should probably move this code into a more common function to do this logic, but we'll leave it there for now. Then we'll say set node type on the expression. Okay, let's check that. That seems to be failing undefined statements. Yeah, okay, so I need to do this into Expa. Okay, so it's still saying expected S32 but found int. And I think maybe that I will I'll return the type from here as well. So we'll just say return type. Then whenever I propagate, I can use that to reassign as well. So we'll reassign type here. Okay, now we get expected S64, but we found S32. I'm going to change that. That's because this is an untyped integer, so it's being changed into the more concrete S32. But we've put S64 in the test here. I don't have the ability to define variables with types yet, and I don't have the ability to call type conversions. So I'm just going to change this to S32 to make sure that the test works. And then yes, so I'm attaching types to these return values here. So I need to add that to the test. This should be S32. This should be S32, and the same up here. Okay, that all seems to be working. And just to check, if I put a return here with nothing, that's failing on this because I need to add the returns to the block here. Okay, so that passes. As soon as I add a 1, 2, 3 here, I should get an error message about an unexpected return statement on line 11. This is line 11, so that's fine. Column 9. This is saying column 2. It is column 2, but Sublime is telling me the column in terms of spaces. So that's fine. I'll add another test here. We'll say explicit return. So we'll have one without the return and one with, just to make sure that it continues to work properly. Okay, so that's some basic type checking of return statements in function declarations.